Okay, so some folks are going to wonder, how do we do this substitution thing with definite integrals? And that's where we pick up the discussion. Let's do the integral from 0 to 2 of x squared times the square root of x cubed plus 1 dx. And let's first say that this is rather challenging. But we think we know the basic idea. We think we know that this thing is going to be u because its derivative is hanging out here, right? It's hanging out there. Like, we're pretty sure that that's a 3, and we're pretty sure that that's a 1/3. So what ends up happening? This integral is 1/3 times the integral of all this stuff gets replaced with a du, and this is the square root of u, which we will write in a form that we can deal with. The question is, what's this number and what's this number? Because see, this is x equals 0, and this is x equals 2. But now we're dealing with things in terms of u. So putting an x number there is not helpful. Putting an x number there is not helpful. Everything has to be in terms of u. So if x is 0, u is 1. And if x is 2, u is 9. So now we have done what we call a complete change of variable. All of the xy stuff is gone. All of the xy stuff has been converted to u stuff. And so now we do the problem as if this were the problem, because whatever the answer to this is, the answer to this is. So how do we do that? Fundamental theorem part 2 says we find an antiderivative. Add 1 to the power, divide by the power, subtract. So 1/3 times 2/3 is 2/9. 9 to the 3 halves, 1 to the 3 halves, and we're done. We do not have to go back to xy terms. We swapped out the original question. We swapped out the original question for something that had the same value. So we don't have to go back to this. We can stay in terms of u if we change the xy numbers to ue numbers. I will demonstrate with one more. And this will be the integral from 0 to pi over 4 of tangent cubed theta secant squared theta d theta. The heck do you, how the heck do you, wait a minute, wait a minute, wait a minute. This thing is the derivative of tangent theta. What if you are tangent theta? I don't want to be tangent theta. Well, too bad, because then your derivative is hanging out right here. Oh, yes, it is. So what if this is the integral of, well, now this is tan theta cubed. That's u cubed. And all of this jabberwocky is du. From where to where? These are theta values. We don't want theta values. This is theta equals 0. This is theta equals pi over 4. We don't want those. We want a u value here and a u value here. If theta is 0, u happens to be 0. But this doesn't always happen. And if theta is pi over 4, u is the tangent of pi over 4. So now we have completely swapped out an integral with thetas in it for an integral with u's in it. So this is gone forever. We can do this integral and be done. How do we do that? Fundamental theorem part 2 says we take an antiderivative, sub, and subtract. And we're done. Substitution works exactly the same way with indefinite integrals as it does with definite integrals. The trick each time is remembering that we get rid of everything that relates to our old variable and replace those things with quantities in terms of a new variable. We change the variable completely so that we can deal with the problem. All right, much more to come when we gather.